What's the answer for this question? I'm trying. If I'm extended to large, then you'll not see. Can you? Let me see if you can see this one here. Can you see it now? Yes. Okay. What's the answer here, guys? Can you? What's the answer? Yeah, you cheated on me this one. That was very cheap. Very, very cheap. It's okay. It's okay. That's a condensation. Now, what if I have a gas going to solid? What we call this? Without going liquid, without going liquid, without going liquid. There's no multiple choice there. There's no multiple choice there. Here, listen, listen. Pull yourself down. Pull yourself down. So here it is. And today is not a Monday, correct? So we have to be vivid. We have a final after this review here. So I have, listen guys, I have solid goes to liquid, goes to gas. Now we can go to gas, gas goes to plasma. Plasma is the gas, as a charged gas. So now if I want to go back and look at the whole thing in the physical processes, correct? It goes back, back, and back here. So going one way, from solid to liquid, what I call this one here, the top. What I call it? You can see it. Technical problems. I don't know why it's not showing. It should really show. It is. Can you see it now? Yes, no?
Yeah.
I have to put myself down with the technology today. It's not working very well. So, and if I go from here, from liquid back to solid, the opposite way, what I call this one, from liquid to solid is what? What? Freezing, correct? We are talking now. Good. From liquid to gas, you said what? Liquid to gas. We have two things. We can call it boiling, or what's the other word? Evaporating, or evaporation. How about if I want to go back to what? From gas to liquid. I do what? Condensation, correct? Now, this is a normal behavior, correct? However, sometimes we have very strange behavior. Some compounds, like dry ice, carbon dioxide, correct? So carbon dioxide goes from solid to gas. So there is no liquid. Liquid is not there. So from solid to gas without going liquid. What we call this process? What's that? Sublimation. What's the opposite way from gas to solid? Deposition. Okay, so this one here, just from here, from solid to gas is sublimation. From here to here, we call it what? We call it deposition. So you get the whole picture now. Dry ice is a gas. Carbon dioxide is a gas. If you put a lot of pressure on it, you not make out of it liquid, correct? You make out of it dry ice. Dry ice, put it in a couple hours, on the air, it will evaporate back to carbon dioxide. Okay, so there's no liquid carbon dioxide. Okay, guys, so the answer is condensation. So you cheated on me on this, but it's okay. So the answer is condensation. This time I have to be vivid and hide the answer, correct? Okay, so I take this one out. Everybody? That's it. Okay, take this one out. And let's take the second one. So, 200 grams of a sample of aluminum, specific heat is this, is heated from 25 centigrade Celsius to 75. How much heat absorbed by the aluminum during this process? Well, did you see this one here in CHEM 101 active? No. What formula we should use? Specific heat. The heat is small q or large q, mass multiplied by the specific heat multiplied by delta T. Delta T is T final minus T initial. Guys, so this following here, mass is 200 grams, 200, 0 gram, 4 sig fix. Specific heat is 0.900 joule per gram centigrade Celsius. The initial temperature is 25 degrees. The final is 75.0 degrees, correct? This is O here. So the difference between them is 50 degrees. So multiply 50 degrees by 0.900 multiplied by 200. What's the value here? How much? Which A, B, C, D? Which one? Work it out. Work it out among yourselves. See what will happen. This time, luckily, there's no answer available for you to cheat on, correct? So you have to tell me what the answer is. So 200 multiplied by 0.9 multiplied by 25, and we have the least sig fix is 3, correct? That's 3 sig fix, 3 sig fix. This is 3. This is 4. The winner is 3. So, which one? Which one? Which one? A, B, C, D. B. I don't know. I'm circling with the big question. Let's see. Let's take my picture out of the way. The answer is B. See here that circle there? And we'll see the answer there. Can I take this one out? Now, those questions, they might not come, but they can't come from nowhere. Are you following me here? So, the answer is B. So, I'll take this one out. Take it out. Who has it? Okay, so let's see the answer. The answer is B. Now, 2 metal blocks and A and B are heated at the same time, the same amount of energy. Block A has specific heat of that twice than block B. But both blocks have, those are the higher chemistry one. I will skip them, but let's do one of them, this one here, then I'll skip. So you have A and B. I mean, it's not really difficult, but this topic is higher chemistry, the principle of chemistry 1 and 2. So we have, it's not really difficult, A and B. But since we did not cover it as such, and those sometimes they bring you something from nowhere. That's the problem with this standardized exam. You have never seen those exams. And whoever that's in the high school, this is high school, the last high school exams, the same thing. What they call the high school exam. 12, after you finish the 12, you have to take an exam, correct? Standard exam. They'll give sometimes questions not even they haven't seen. Those are going to nursing. They have the what's called the TS or something. You get some questions sometimes standard exam you have never seen before. Same thing when I went 36 years or 38 years ago, or whatever, in Colorado. We have GRE exam. The GRE exam analytical, I have never seen them before. I have no clue. Just put my eyes like this, and that's what you have to. If you are running out of time, the best way is put your eyes covered, and then mini, mo, and then click on one option, C. Then all the rest, C. Don't start guessing A, B, C. No, you're running out of time. You have no time. Don't start laughing at me. I survived 38 years ago in Colorado. I took GRE. Failed twice. Third time I passed. My advisor would say, "You're a very good student. How you passed this time?" Well, he gave me money to fund my workshop. I went to workshop GRE, and then one of the workshop tips: put your eyes covered, closed, pick up one choice, and because every time I miss 20 to 25 questions, I have no time. I keep them what blank. They said, do not keep any question unanswered or blank. You have to answer it with educated guess, but you have no time, then select one choice all over. Guess what? I passed. I have never even read those questions, ever. I passed. That's the main thing, you pass. Those are what I don't like in the standard exams. The time is not there, and some stuff I have never seen in all my life. So anyway, A and B, two blocks, A and B metals, correct? And they are heated with the same amount of energy, correct? And they have specific heat, same here, Q, same value, Q of A equal Q of B. Those are equal, okay? Now, the only thing is different is specific heat, correct? Specific heat that of block, specific heat of A, twice that of the block B. So specific heat of this, so this is specific heat. This is 2 specific heat. Twice, correct? The A is twice. The block A has specific heat capacity twice than block B. Both blocks have the same mass. The mass is the same. So let's put here mass. Mass is the same. Mass of A equal mass of B. Specific heat, they are the same, but that's the A is twice. Correct? Which of the following statement is true? Block A will experience a greater temperature increase than block B. B will experience a greater temperature increase than block A. Both blocks will experience the same temperature increase, and the temperature increase with each block will depend on their initial temperature. So what I will do, I'll put for you both cases here, correct? And we will see. Let's take this one out here. Can I just take this one out and do this now for one? Okay, guys, let's do this. Q of A, mass of A, correct? Multiplied by the specific heat of A, which is twice specific heat of B. Let's put here. Okay, and multiplied by delta T. This is A. Q of Q of B, mass of B, okay, multiplied by specific heat, which is half a specific heat, because this one A is double. SB of B is half, correct? Multiplied by delta T of B, just to visualize. So mass of A, I'll turn this one here into A. Those masses are equal. Okay, so what I want out of this here, when I compare all those together here, so mass of A multiplied by specific heat of A, this is A here, multiplied by the specific heat of the second one. This is not half. Is it half or twice, correct? Twice A. No? Somebody's checking the head. Specific heat of this one H, correct? Whoops. We did not do this one here. Not correct. Delta T1. Delta T A equal to mass of A, correct? And A is twice. They said A has twice the specific heat of B. So this is specific heat of B multiplied by delta T B, correct? Now, mass with the mass cancels out. They are the same, correct? I'm just canceling those. Come to the idea, what is the relationship between delta A and delta B? So this one here is twice, correct? Or the has a specific heat capacity twice. So this is 2. That's twice is B. So this one here out, this one here out, but this one here will be 2, correct? So that I have this one here relationship. Correct? That's the relationship. Because A is twice than B. The masses are equal. So I have delta T A to delta T of B is what will be? Cross multiply. This is A, 1 and 2, correct? Half. It means what? Delta T B, everybody's following here, is 2. Am I doing this correct? Everybody's following? The specific heat of B, twice of A, or A is twice than B. So you did not follow me. We have to be careful, because the relationship will be of those here different. So A, CB, and CA here. This is A. Okay, so let's do it just carefully. This is A, specific heat of A. A is twice of double. So A will be here. So this one here is how much? Is twice CP. Correct? So yeah, that's correct what we did. Cancel themselves out, and we have this relationship. This relationship is correct. So now you can tell me which one you will be choosing out of those here. It's about delta T, asking about delta T. Which one? Which one? Specific heat is B, but the specific A is twice of B. Means this one is twice of B. So A The block A will experience greater. It looks like it because it's twice, correct? It will be twice. From this one, I can say that's twice this one here. Correct? Let's see. The answer is not A. Is it A or B? B. Well, that's the B will experience greater the temperature increase than block A. Yeah, it's you express it. The answer is correct. Means if you have multiplied this by this, it will be twice this. So delta B is twice indirect proportional to the delta A. So delta TB is twice greater than delta A. So B will have more than A. Make sense? This is one. This is twice. But when you the relationship delta TB in the relationship, specifically it is indirect relationship to both because of the 1-to-2 ratio. So it's the answer is B is correct, not A. So don't worry about this. As I said, those questions here. Let's see if they have another one. But as I said, the answer is B. Now, yeah, that's changed now. Okay, so which answer is this? Which answer? You have strontium group 2A, and strontium has atomic mass in the top. Atomic mass always the big number, 90. Atomic number is 38, correct? The atom strontium has contain how much? How many electrons, how many protons, how many neutrons? So the atomic number, atomic number, guys, is what? 38, correct? Which is equal to the proton number and equal to the electron number. So electron, proton, 38. How about the neutron? The neutron is 90 minus 38. Will be 2, correct? 8 and 5, 52. So neutrons number. So 38, 38. 38 protons. Where's the number? A, B, C, D. Which one? A. Sounds good to me. The answer is A. That's not a guess, but we solved it though. Not a guess. Okay, good. Any question about this? Any question? Okay, so atomic number is number of the protons at the same time number of electrons in a neutral atom. If the atom is charged, then it's a different story. Okay, positive charge you have to subtract, negative charge you have to add. So take this one here up. Let's see. So let's see. So is 2. So let's take this one here. How many electrons are in carbon 6 atomic number and 14 atomic mass? How many electrons? We just said how many? How many? C? Okay. 6? No, 6. It can't be 6 is correct, but it can't be C. C is 8. It can't be. So the answer is correct. Number of protons equal number of electrons equal the atomic number, 6. So is the number correct? What they did? Oh, sorry about this. I did what? Protons and electrons. Let's speak about neutrons. Well, neutrons is easy. So 14 minus 6 is what? 8. Atomic mass minus the atomic number will give you atomic number 8. Okay, so I'm sorry. Bless you. So okay, that's challenging here. That's no answers. Okay, somebody saw the answer already. So using models particles below, which are isotopes of the same element. Give you protons, neutrons, and electrons. So, which one of those? Which are the isotopes? Isotopes are they having what? Different neutrons, but the electrons and protons are equal, correct? So electrons are the darker one, and the proton is the blank one, and neutrons the grayish one, the gray color one. So, well, so what do you think? You go by the number, correct? Number of electrons equal number of protons. So the number of the darker dots equal the number of the blank dots. Okay, so you can. How about option? This option, is it correct? Why is not correct? What? It's not equal amount? Correct. How about particle 3? Yes. Why? The number of neutrons is not equal, correct? This is equal, the same thing, the same problem. This is equal, the same problem. This is 4 neutrons to 3 protons, correct? So, and the electrons are outside here. You can see the electrons are outside, so equal to number of what? Of protons. So the answer is particle. This is correct. Am I correct? That's different. So particle 1 and particle 3. Particle 1 is said B. How about 3 and 3 and 3? Particle 1 is, this is particle 1, 3 neutrons, correct? And 3 what? Electrons. Are they? Oh, okay. I see what they. The question are combining what? Which one are combining, making an isotope? Okay, so those, the original one plus the different one. Okay, so see here. Answer is B. That's correct. So which pair represent isotopes? Which pair represent isotopes? So the best thing here in solving this, look at the atomic number and eliminate the other ones. So let's look at the atomic number. I have here, the first one is 34 and 36. Those are 2 different elements. They are not isotopes, correct? They are not isotopes. Isotopes, they have to have the same atomic number, the same protons, correct? So you can eliminate the first one. Okay, guys? How about the second one? 48 and 50. That's, you can eliminate this. You have to have the same one. Which one has the same atomic number? C, 92, 92. Those are different. So C, they have the same atomic number. But the atomic, the number of neutrons is different because the atomic mass is different. This is 235, this is 238. Correct? Make sense, guys? Okay, so the answer is C. Okay, here it is. What's that? B or C? Today I'm not in good shape, so I give you the answer. But so did I circle this? And what did I say? C? Well, I have to get my reading glasses inside. So we have the correct answer, but the multiple choice is not correct. Okay, so let's a pair of isotope has we talked about this. Same number of protons, same number of electrons, different number of neutrons, correct? Now we have to have the choice correct, multiple choice correct. Which one? Same number of protons but different number of neutrons. Yeah, number of protons and neutrons but different number of electrons. That's B. You can eliminate. Same number of protons, the same number of electrons. You can eliminate C as well. D, the same number of neutrons and the same number of electrons. You can eliminate D. So the only left is, what choice is left is the first one, correct? A. Okay, it's A. Okay, guys. So in all neutral atoms, there are equal numbers neutral atoms, not charge, positive charge or negative charge, neutral atoms. The number of what is equal to what? The number of the protons equal number of what? Electrons, correct? So A, we can discard it, correct? That's not true. Neutrons and electrons, C can be discarded. Positron and electrons, that's not true. Positrons is radiation. Okay, electrons and protons is D, correct? So it's D. The answer is D, correct? So those are the easy ones. Okay, so which element is represented by 24x56? This one you need to look at the atomic number. Anytime I want to recognize any element, I have to look to its what? Atomic number, not atomic mass. Atomic mass can be changing because number of neutrons are always changing. It's isotopes found in nature, but atomic number is not changing. Atomic number inside this proton inside the nucleus is not changing. So what will be this X? Look at 24, atomic number 24. Atomic number is always the least number, not the greatest number, always the smallest number. So always the smallest number, always the smallest number. So what's this, the A, B, C, D? I'm not looking. So you tell me which one. What's that? D, chromium, correct? I saw it. I picked it up. 24, correct? So answer is. Oh, you are cheated on me. The answer is there. Just pointed it out. No, I'm kidding. I'm just kidding. Okay, I'm just kidding. Okay, which statement is true? The nucleus of an atom contains neutrons and electrons. The nucleus of an atom, that's not the atom, the nucleus inside the heart and the core of the nucleus of the atom is inside. There are no electrons inside. Electrons are zooming outside, spinning outside the nucleus, correct? So A is out. Atomic number of an element is the number of the protons in one atom. Is this true? Yes. Atomic number is always number of a neutron, especially if they add the number neutron. Although protons will not change, it's always stable and same number for an atom, correct? So the answer is B. How about C? The mass number of an atom is number of protons in a nucleus plus number of the mass number is the number of the protons in the nucleus plus the number of electrons. That's not true. The atomic mass or mass number is mass of the protons plus mass of neutrons, correct? The number of electrons outside the nucleus is the same as the number of neutrons in the nucleus. That's not true, correct? That's not true. So the answer is what? State the answer is B. Atomic number is the number of protons. B. Yeah. So, okay. You saw the answer there too. So I have to hide here. I have to hide. At least one choice is not there. So, what is the atomic number of an atom that has charge +1 and contains 18 electrons? So now we have X atom here. Put yourself this one here. X atom, correct? It has the charge of +1, correct? And contains 18 electrons. It contains what? 18 electrons. So contain 18 electrons. So what do you think? What is the atomic number of an atom that has a charge of +1? 17. It has 18 electrons. So 18, 18 means if you have 18 and you have this one plus, you have to subtract. If it's negative, you have to add. Minus 1 is what? 17, correct? You have 17 electrons and 17 protons to begin. So the neutral atom will have 17 electrons and 17 protons. Now, if you subtract this one here, minus 1 electron, this one will look 17 protons as is, and will be 18 electrons. This is protons, sorry. Are you following me now? Everybody is following? Yeah, so the answer is, what? The answer is 19. The answer, they said 19. Let's look what we have done. If you subtract, because +1 means you are taking 1, correct? You are not adding. So if I have nitrogen 3 minus, and I have nitrogen. So nitrogen has how many electrons equal the protons is what? How many electrons is 7? It's atomic number. And it's 7 what? 7 protons. Add 7 electrons. Now, this one here, you have to watch. This one for this. Correct? Is this following? Now, N3 minus will have what? 7 protons. And how many electrons? 10 electrons. Okay, guys? This one X, we don't know. So suppose is we said, they said what is 19? This is 19. Oh, okay. I see what. Their answer is correct. Their answer is correct. Ours is not correct. 19 minus 1, because the sum, that's the end, is 18 electrons. Make sense? So let's do here. Let's do theirs. Are you following what I did with nitrogen? Nitrogen will have 3 minus, will have 10. But if you look at this one here, X, Okay, so you say the 17. 17 is not correct. It has to be 19 protons, 19 electrons. Then when you have to go to x plus 1, you take 1. So that's the leftover after the end. So that's what it says. So plus 1, so 19 protons will remain, but then electron is losing 18 electrons. So the answer will be 19. That's correct. When you have to subtract, it's just quite the opposite what we have. Okay, guys? So, which atom has the most neutrons? Neon 20, fluorine 35, phosphorus 32, sulfur 35. So, which one you think? Which one has the most neutrons? Well, you can use the periodic table, correct, to get the number of neutrons. But if you have to look at the whole thing. So neon, how many neon? What's the atomic mass of neon? Is 20, correct? 20. So the atomic mass is 20. When I say those are isotopes. This way, when we write those elements, those are isotopes, correct? Those are isotopes. So 20 minus 10, this is 10. 35, that's isotopes. 35 minus chlorine is 17, correct? 17, how much is it? 8, correct? 18. This is 32 minus 15. This is 7, correct? 17. And this is 35. Sulfur is 16. Equal to 15 is 19. So which one? Yeah, so sulfur will be at the highest. Those type of typing in the elements dash atomic mass. This is the isotope. Those are 4 isotopes. So correct. So the answer is what? Yeah, D. The answer is D. The answer is D. So how many neutrons are in? Now you have to watch. It's very tricky. They put for you chlorine. Oops. But we have to solve it. Even if you saw the answer, don't worry about the answer. Chlorine, and it has -1. This is 37. This is 17. Okay, so will be what? Yeah. The question is be correct because 37 atomic mass minus atomic number, proton number is 20. But how about the minus? Does the adding electrons will affect the number of neutrons? The answer is no. Are you following me here? And if I have element with chlorine plus, for example, does it affect? No. Because what we are looking at is taking electrons or taking electrons in or getting rid of 1 electrons will have no effect on the number of neutrons. Only one is because atomic mass is sum of neutrons and protons. We discard electrons, correct? So how many protons and neutrons and electrons are in the presence of titanium, correct? That's titanium, which is, look at this, it has titanium 3 plus, and it has 47. 47 and how many? 47 and 22. So your intuition will tell you do the same thing first with the proton neutron, and you have a positive, then the electrons will be will be taken out, correct, by 3. So protons, how many here? How many? 22. Neutrons, how many? 25. Now this is the problem with the charge. Electrons are positive, that means 22 minus, so the positive will turn to be minus here, minus 3, correct? Minus 3. So how many? 19, correct? So which one is correct? A, that's correct. Okay, so answer is A. So which ion has 26 electrons? This is very simple, but you have to watch for the charges. So which one has the 20? Which one has 20? 26, not 20, 26 electrons. Which one? Fe? Well, let's see Fe. Somebody said Fe. Let's check it out. What is the atomic number of Fe? Let's see. Fe is, that's the atomic number, correct? 26. Is it 26 or 28? 26. Okay. And how about nickel? Nickel is 28. Okay, let's see. We'll see. Those are number of protons equal number of neutrons in neutral charge, correct? And copper, how much? 29. And chromium, how much? 24. Now, if I put this one 2 minus 2 plus, means you have to take what? The 2 plus you have to take. So electrons here will be the first one, 24 minus 2, 22. So this one is not. How about this one here? 26 minus, this is 2 plus, correct? Will be 24. This one is not. This is 2, will be 28. Minus 2 will be 26. This is correct. How about this one here? 29 minus 2, 27. So this is not. So the answer, if it is 26, will be nickel, I think. Came out correct? Yeah, nickel. The answer is nickel. The answer is nickel. The answer is nickel, correct. Answer is nickel, correct. So a sodium ion differs from sodium atom in that sodium ion has fewer electrons, is an isotope of sodium, exists only in salt solution, has negative charge on its nucleus. Which one? That's easy, correct? That's easy. We don't have to cheat on that, correct? So which one? E? Then we don't have E. How much? B is an isotope. Isotope will have different what? Neutrons. But it said sodium is different from in that sodium ion is the isotope of sodium. How about, well, if you say isotope, it does not give you isotope has nothing to do with the sodium ion is different. No, that's not true, because look, sodium is neutral is this, correct? That's sodium neutral. This is sodium positive 1, correct? And this is sodium isotope. So which one is really represented here in those? This one here has what? Look at this. Sodium has, it is 19, correct? How much is the sodium? 11. 11, correct? So 11. And this one, how much electrons, correct? 11 electrons, 11 protons. Here, 11 protons, but then this plus 1 means 10 electrons. Here, it does not matter, it has 11 electrons and 11 protons. And neutrons is 23 minus 11 is 12. So, look at this. Then which one is out of these 4 options? How about A? Can you consider A is correct? Can you consider A is correct? Because electrons in a charged sodium ion, you have fewer electrons, 10. This one has what? 11, neutral one. And the isotope will have 11. So that's the reason, correct? Are you following me here? So the answer will be, without thinking, this has ions will have always fewer electrons. And the answer is A, correct. So two isotopes of theoretical hypothetical element X exist with abundance of 30.00. The atomic mass is 100, and X this 100, and then abundance 70 for X 101. What is this one? I will wait. Let's do it. Let's calculate and tell me how much you got, and which one is correct, and which one is correct. Calculate and tell me. Is this coming in the final exam? Yes, in the lecture, not in the lab. In the lecture, yes. The average weight atomic mass number that will come. I'm sure that it will come. So everybody knows how to do it. Everybody knows how to do it. Everybody knows the formula of it. There's too many formulas. I know that's too many formulas. But this will come in the final exam for sure. So how much? So let me write the formula for this. The abundance of the first one multiplied by its atomic mass. Since this is 100, absolute value, that's the atomic mass of the first one here. That's the atomic mass. Here, 100 multiplied by abundance, 30, divided by 100%. That's the 100%. This is the first one. Plus the second one is 100 atomic mass multiplied by the abundance is 70. Okay, guys. So atomic mass multiplied by its abundance divided over 100. Abundance over 100. So over 100, here it is. So atomic mass multiplied by the abundance, and the abundance has to be divided by 100. So now this is absolute value. So this is absolute value. So it's not part of the secret. So we will have four significant figures because the decimal has 4. So 4 sig figs. So how much is it? Come on, guys, you are letting me down, really. So, guys, come on. 100 of 100 cancels out. How much is 30 My goodness. It's like 100 over 100 out plus 70. And then with the decimal, of course. How much is it? 100. What is it? 100 of 5? 100 of 7? 100 of 5? I see that. Hold on. I made a mistake here. That's 70 is 101. Sorry about this. Yeah, I need my glasses today, so it's so tiny. This is not correct. This is 100. The math not correct. This is 101. So you get the idea. So this is 101. So it means this one here will be a little bit more than 70, correct? More than 70. So more than 70. So which one you tell me which one? So this one here is. So how much is it? E, C. Somebody said C. I don't know. I did not calculate. So, but one is 100. One is atomic mass 100. The other one atomic mass 101. So you said C. Okay, so C. Sorry about that. I saw it 100, 101. So the answer is C. Somebody calculated. The answer is C. Okay, good. That's good. So, okay, guys, which group number contains, couple minutes and then we are 2-3 minutes and then we are done. Group 1, which group number contains the most diatomic molecular elements? You look at the table, dimolecular element. Which one present in nature with dimolecular element? Which one you think? Fluorine in nature, F2. Chlorine, Cl2. Bromine, Br2. Iodine, I2. And stantine, IT2. So your tip will be what? 17, group 17. Correct? The 16 is sometimes they can be 2 or 4. Correct? The 15 with 2 and sometimes 8, sometimes the like sulfur is not like oxygen. Oxygen is O2, but sulfur is S8. So the answer is 17, correct? The answer is 17. That's the correct answer. So I will stop here. So we have a final today in the lab. So I have to rush to the lab. So I'll post this one here for you guys. Good luck. Anyone with the last? I'll stop here. Just